Hello and welcome back. We're going to be jumping into section 7.2 now, which is applications of linear equations. Now this section is probably going to be one of the most challenging sections of the course. It's all about word problems, and which I know are not people's favorite things to tackle. So, just bear with it. Try to absorb as much as you can from it. If you're not perfect with it, it's okay. So, the first part of this, though, is just getting into some translations from words to mathematical expressions. I'm pretty sure this page is correct, but it's one of the first pages of the section. So if it's not quite right, just look for it and you'll find it. Now, some of these terms you've probably heard before. Some of them you might not be familiar with, but once we do a couple of examples, you'll see where we're going with it. So the first one says a number decreased by 4. So decreased by. What operation is that? Yeah, it's subtraction. Now, as far as a number, though, a number, we can use a letter to represent that, a variable. Now, typically, you want to use x. That's pretty much what they steer you to use, but you could use any variable you wanted. But let's use x because it's the most common. So we got x minus 4. And that's it. That's all you have to do as far as translating. Now they get more interesting as we go, obviously. -3 increased by 5 times a number. Now we can write this a few different ways. So if we just kind of come straight down with all the translations, we would get something like -3 increased by, which is plus, 5 times a number. So 5 times x. So we could write it this way, and it's not super compact or anything, but it's true. It's accurate. Now, if we wanted to rewrite this a couple of other ways, or at least one other way, I would like to put my x's first. So I would say 5x. You don't need the times symbol in there. And then just -3. And that says the same thing. Now, going back to this problem here, what if we flipped it around? Would it be the same thing? 4 minus x. Is that the same as x minus 4? The answer is no. Subtraction is only one direction. So it's going to be right one way or the other. It won't be right both ways. So in this case, you got to be careful. So subtraction, there are some phrasings that will flip it around from what you would think. Now, just to kind of illustrate those or to highlight those, subtracted from, that phrasing flips it around. Fewer than, that's another one that flips it around when it's subtraction. So keep an eye out for some of those and just be careful. We're going to see some as we go through this, but we might not see a lot of them. So take a look. Now, this next part just gets into the steps for solving an applied problem or a word problem. So read the problem carefully until you understand what is given and what is to be found. Assign a variable to represent the unknown value using diagrams or tables as needed. Write down what the variable represents. If necessary, express any other unknown values in terms of the variable. So what does that mean? Well, sometimes you're trying to find multiple things in a problem, and one thing is based off of another one. So the process for that is to say, well, which one do I have to know first? If I know this one, then I can figure out what this one is, because this one's 10 bigger than this one was, or something like that. So whichever one you have to know first, that one's going to be your x. And then you can create an expression for the other one. And there might be even more than just two. So that's kind of the idea. Which one do I have to know first? And that's my x. And so we'll see that in action. Okay, step 3, write an equation using the variable expressions. Solve the equation, state the answer, does it seem reasonable, and be careful about units. Units are important. And then check the answer in the words of the original problem. Okay, so let's try a couple of problems. Now the first one is not really giving you a lot of context. It's not you know, talking about apples or dogs or whatever. It's just, you know, it's still looking at a problem with x. So if 2 is added to 5 times the number, the result is equal to 5 more than 4 times the number. Now, with a problem like this, you're going to say, where do I start? Where do I start? Start right from the beginning of the problem and just start to translate it and see what you can develop. So if 2 is added to, okay, so 2 plus 5 times a number, 5 times a number, so 5x. The result is, okay, so the result, that's an equal sign. 5 more than, okay, so more than is addition, 4 times the number, 4x. And that's it. So some of these problems are going to be quick that way, in which you can just translate it from words directly into an equation. Other ones, not so much. So we're going to see some of those soon. But once you have it written out, now you've got to solve it. So now we go back to our steps from section 1 and get this broken down. So the first thing we can look at is our x's. So remember our rule was, our informal rule was to move the smaller one. So let's subtract 4x. And so we got a 2 plus 5 minus 4 is 1, so 1x. We don't need the 1 though. And now we can get rid of the 2. So x equals 3. All right, and now in your answer, how do you write your answer formally? Well, you don't need the x equals, they just want to know what the number is. So the number is 3. Not anything fancy, but that's kind of how they want it. So let's try one with a little more meat to it. In the 2008-2009 NBA regular season, the Boston Celtics won 2 more than 3 times as many games as they lost. The Celtics played 82 games. How many wins and losses did the team have? So the Boston Celtics won 2 more than 3 times as many games as they lost. So they have wins and losses. So they're trying to figure out how many wins and how many losses they have. So which one of those 2 pieces or 2 things do you have to know first to figure out the other one? If you know the wins, can you figure out the losses? Or do you need to know the losses first to figure out the wins? So you got to kind of decide which one's my starting point. And the way this is written, it says that they won 2 more games and 3 times as many games as they lost. So you really need to know how many you lost first. Once you've determined that, you can say x is equal to the number of games lost. All right? So now we've got x, the number of games lost. So now we should be able to create an expression for the number of games won. So number 1. So what would that be? So now we got to try to translate it. The Boston Celtics won 2 more than, so 2 plus 3 times as many games as they lost. Well, the number of games that they lost was x. So 3 times x. That should be the number of games won. Okay, we're getting there. The setup is the hardest part. So now we got to use this next bit of information. The Celtics played 82 games. So now we got to kind of tie all these pieces together into an equation. Now, a common answer would be to say, well, so 2 plus 3x equals 82, right? Well, no, it's not right, because that is just the games won. The total games, which includes the games that you lost, that they lost rather, is got to be in there as well. So you need both. You need the losses and the wins. So again, there's the losses, there's the wins, there's the total. So now we can start to solve this. So combine our x's. We got a 1x and a 3x, so a 4x plus 2 equals 82. Lose the 2, and then divide by 4. So x equals 20. So now you should go through and write your final answer. So the question wants to know how many wins and how many losses did the team have. So if x is 20, so that's the number of losses. So losses equals 20 games. And then the wins, how do we figure out the wins? You can do it one of two ways. You could say, well, I know the total is 82, and if I take away 20, that's 62 wins. So, and that would be right. And that's one way to do it. The other way to do it would be to plug in that 20 back into your expression for your wins. So 3 times 20 is 60, plus the 2 is 62. So either way, you get the same result. So again, the hardest part is the setup. It's going to be that setup. The solving part, I think you're starting to get the hang of it, but it's that setup that's going to be a pain in the rear. So let's take a look at another one in the next video. Haha, psych.